Today, we're going to be looking at the Anycubic Kobra S1 Combo, which, if you're not already familiar with, is a fully enclosed Core XY style printer with a multi-material unit for multicolor printing. I'll be taking you through the unboxing, setup, and getting started with the printer, including some basic slicer walkthroughs, some tips and tricks, and setting up more advanced multicolor prints later in the video. I've got a wide range of print examples so you can get a really good sense of the print quality from this machine. And the Kobra S1 has all the bells and whistles, including a really nice touchscreen interface, carbon filter system, advertised 600 millimeters per second top speed, and a hot end that can reach up to 320 degrees for printing more advanced filaments. It also has some smart features like AI print failure detection using the onboard camera, and apparently it can also detect loose belts. The build volume is a very generous 250 by 250 by 250 millimeters tall, and you can control the printer through their app and send prints directly through the Maker Online model repository website. The ACE Pro unit can fit up to 4 different rolls of filament and actually has an integrated drying system, which is very convenient as you won't need a separate dry box. You can also order the S1 with a second ACE Pro, and you can chain them together to print up to 8 colors at once. So this all sounds very promising, and if at any point you've got the itch to purchase the Kobra S1, please use the link in the video description down below. It goes a long way to supporting these kinds of very in-depth videos. They take a lot of time and effort to produce. So let's get started. We'll begin here with the unboxing, and the Anycubic Kobra S1 Combo comes in a well-packaged single box. Some other brands, their multi-material units come in a separate box, but looks like Anycubic planned this out perfectly as they were able to get everything shipped inside a single box. You can see right here, right inside of the printer itself, we've got the ACE Pro, and to get that out, we need to remove this plastic shipping bracket, and there are a few screws marked with those red arrow stickers. And on the top of the printer, if you remove the lid, there's also a sticker on that that shows you exactly what to do. Now we can pull the ACE Pro unit straight out of the top of the printer, and we can also remove the accessory box. There are 4 more screws marked by those red arrows that need to be removed in order to get this shipping bracket out of the base of the printer. Once you remove that plastic bracket, this will reveal the print bed underneath. And the print bed is also held in place with 3 more screws, 2 at the front, 1 at the back, and this was to keep it from moving around during shipping, and you'll want to remove those before we can turn the printer on. Inside of the print chamber, there's a few pieces of packaging and foam that need to be removed, one from the filament chute at the back, and there's a zip tie holding the print head in place. We can cut that, remove the cardboard, and now the gantry is free. Next, we'll take a look at what's included inside of the accessory box. So in there, you'll find a bunch of electrical cables. 2 seem to be regular power cables, and one of them seems to be some cable for the ACE Pro unit. There are also some bags with small hardware and spare parts, a spool holder, as well as a carbon filter, and finally the filament hub. Next, we can remove the ACE Pro from its own packaging. All of the clear panels are nicely protected from scratches, and on the front of the unit, you'll find a sliding latch, and you can slide that open the ACE Pro, and inside, you'll find some accessories. What really sets the ACE Pro apart from its competitors is it has an active heating element. You can control the temperature and keep your filament dry. No need for an external dry box anymore. You also may have noticed in my ACE Pro accessory bag, Anycubic included this small project kit. And this one is the mini Bluetooth speaker kit. Very cool. The Anycubic Kobra S1 comes mostly pre-assembled. There is very little to do here. However, one of the things we can do is install the carbon filter. The filter itself was included in the accessory box, and it just gets shoved into this little cubby or compartment at the back of the print chamber. And there's a cover that just simply snaps on and off. Then, looking at the back of the printer, we can install the filament hub. And the filament hub gets attached first with the PTFE tube coming out of the top of the rear of the printer. And then there's a few locating features at the back of the filament hub that we can press into the back of the printer to locate it. There's also a small Ziploc bag that has hardware labeled for filament hub, and we can install those 2 screws, permanently now attaching this to the back of the printer. The hub connector has 6 pins, and at the back of the printer you can see there are 2 receptacles. One has 4 pins, the other has 6, so it's pretty clear where we're going to be plugging that in. Then we can make sure the lid is installed at the top of the printer, and from all of the pictures and media seen on the Anycubic website, it looks like that lid can safely support the ACE Pro, so we'll place that on top. Now we can connect the ACE Pro to the printer. We'll grab this cable from the accessory kit, and you'll see one end of the cable has 4 pins, and the other end of the cable has 6. The 4 pin will go into the empty port in the back of the printer, and the 6 pin will go into the bottom port at the back of the ACE Pro. And the ACE Pro also has its own dedicated power cable, likely because of that active heating element inside. Finally, we'll connect the PTFE tubes from the ACE Pro to the filament hub, and to do that, you need to remove these blue plastic collet clips. Now we can take our PTFE tube, also included in the accessory kit, and we can push those into the 4 ports at the back of the ACE Pro and then reinstall the collet clips. Just make sure those clips are pushed in as far as they can possibly go and give them a slight tug to make sure they do not come out. On the bottom of the filament hub, there are 4 more ports where the other end of those PTFE tubes will go. Also make sure that they are fully engaged inside of the filament hub. And this is what it should look like with the tubes having a nice gentle bend. Make sure yours aren't pinched or you'll end up having problems. Now we're ready to set up our brand new machine, and the first thing you'll do here is turn the power on with the switch at the back of the printer, and you'll be greeted with the Anycubic splash screen. You'll select your language, you'll select your region, and then you can connect to your Wi-Fi network. Anycubic also has a phone app which you can print directly from. We're not going to be covering that in this video, so I'll go ahead and skip that. And then it asks you to insert the USB stick included in the accessory kit. The skip option was there, but it appears that you cannot skip that, and you do have to install the USB stick, at which point the printer will enter into a self-check mode and the calibration will begin. If you've never owned a printer with resonance compensation, then do not be alarmed when the printer starts to shake pretty violently and make odd noises. This is totally normal, and it's trying to find its own resonant frequencies so that when printing, it can avoid those to prevent print artifacts. When it's all said and done, we're ready to enter the main menu. There's an icon that looks like a bunch of rolls of filament. When you click on that, you can access all of the properties of your ACE Pro. If you had a second one attached to print in a total of 8 colors, you could access that, but for now, just the single ACE Pro is my only option. The next icon down from that is the printer controls, where you can do things like set the nozzle and bed temperatures, enable fans, and move the print head around. Below that, we have the printer settings in general, where you can change your network settings, turn on and off the internal LEDs, toggle features like the belt tension detection, and more. But if you click on the device settings, this is where you may be prompted to update the firmware. I would highly recommend you check for a firmware update before starting your journey with this machine, because I don't have any idea which version of the firmware your machine might be shipping with. When the firmware update is done, you can reboot the machine, and now we can finally load in some filament into the ACE Pro. Anycubic sent me a variety of colors of their own brand, and this is just regular PLA, so we'll go ahead and load this into the ACE Pro. We'll flip open the lid, and we'll feed in the end of the roll into the orange port at the front, and the ACE Pro will grab onto that filament once it detects it and start to feed it in. Now, according to the Anycubic website, the ACE Pro does feature an RFID tag reader. This means that it can auto-recognize certain filaments with RFID tags, likely only from Anycubic. Now, this material that Anycubic sent me does not appear to have RFID tags on it, so in this case, it seems like the ACE Pro was not able to recognize them. So for these rolls and generic filament from other brands, you can go into the filament section, tap on the spool that you want to edit, click on material, and for this, I'll select PLA, and then you can also edit the color. I'll repeat the same process for all of the other colors that I just loaded in. And you can also see in this menu, this is where you can toggle the filament dryer on and off. And the final thing we need to do before we can get started printing is head on over to the Anycubic website, go to the Help Center, and click on Firmware and Software. In the future, their website might change, but right now the link to the Anycubic Slicer is on the left-hand side, and I'll be personally downloading Anycubic Slicer for Windows. Once installed, you'll want to configure your slicer for your specific printer, and in this case, it will be the Kobra S1. So you can see that the profile has been selected with the 0.4mm nozzle, which comes installed standard, and I can just click Finish. And now you can sign up or log in to a profile, and this will help you down the road with accessing your printer remotely. So now we're ready to finally print something, and Anycubic has their own model sharing website called Maker Online, and this is where I found some printable parts for that Bluetooth project speaker that was included in my accessory kit. So I'll go ahead and download the 3MF project file and import that into the slicer. Now it looks like whoever created this design intended for it to be printed on the Kobra 3. So we'll use the drop-down menu to change the printer, and instead, of course, we'll be selecting the Kobra S1. Now this video isn't going to be an in-depth guide into slicing, but if you are new to 3D printing, I will take you through a few basics. So if I do use the button in the top right-hand corner to select Slice Plate, you'll see that we get a preview of the print. And one thing you'll notice right away is that there are these blue highlighted sections which are overhangs, which means those areas of the print are going to be printing in the air, which is not possible. So we need to do something about that. We can go back into the Prepare tab, select that part, and then select the Paint on Support tool. I'll just select the Fill option and click on that face, and you'll see that whole face get filled in green, as well as a few others where I believe there might be some problems when it comes to printing these overhangs. Now I'll just press Escape on the keyboard to exit the painting tool, and on the left-hand side, we'll find the menu with a lot of our print options, and by clicking the Advanced button, I can get access to a lot more print parameters. I'll click on Support, I'll enable supports, and then in the drop-down menu below that, I'll go ahead and select Manual Tree Supports, and I opted for Manual Supports because it's only going to now generate supports in the sections where I painted them on using the Support Painting tool. And then I'll go ahead and reslice this, and things are looking quite a bit better, so we'll try and send this off to the printer. But first we need to actually establish some sort of connection from our slicer to the printer, so we can click on the Workbench tab, and then click on the Add Printer button. And as long as your computer and the printer are on the same wireless network, it should be able to scan your network and recognize the Kobra S1, and you can just click on Connect Printer. And once connected, it's not very obvious, but if you look in the top right-hand corner, you'll see a little message that says New Firmware Version Available for Update, so I will click on that. And it's not the printer itself that needs to be updated, but it's actually the ACE Pro. So it looks like we can conveniently update the ACE Pro firmware over the air, and once that's done, we can get out of here and go back to the Prepare tab on the top left-hand corner, and we can now properly set up our filament profile for the filaments that we've loaded into the ACE Pro. In the filament section, there's a few options, and one of those will be a button to synchronize the filament list with whatever you've got loaded into your printer. So I'll go ahead and click that, and you can see the orange, white, black, and gray are now synchronized. And if I click on the Objects button, I'll get a list of all of the individual parts on the build plates, and I can select all of them or select a few of them, and using the numbers on my keyboard, for example, if I press the number 2, the white PLA in slot 2 will get assigned to the corresponding parts. I'll reslice this job one more time because now it's using the Anycubic PLA profile, and I'll click on Remote Print. And before running the first print, you can enable or disable a few options. For this, I'll just enable the bed leveling, so it will run the auto bed leveling procedure one more time before actually printing these parts, and then the print will of course start. Now unfortunately for me, this was also the start of a problem that took me a little while to figure out and fix. So this first print just flat out failed, and the extruder stopped extruding plastic and it was printing in mid-air. When I've seen this in the past with other printers, sometimes you just need to increase the nozzle temperature. So I bumped up the nozzle temperature several times and eventually got to a print temperature of 250 degrees for PLA, which is abnormally high. I even tried different colors like orange, and you can see that the orange did print, and it looked decent when it did print, but I figured the machine could do better than this, and I was getting way too many failed prints, so I definitely knew that there was something going on. I took apart the hot end several times, and the first few times I didn't notice anything obviously wrong or out of the ordinary, but at some point I had had enough of getting this filament clogging detected message, and that's when I tore into it one more time and finally figured out what was going on. Looking inside of the melt chamber, you can see here that I've got the gray filament that I was just printing in, and it seems to be jammed inside of some unmelted orange plastic from the previous print, which I found extremely odd because that gray print failed after about 4 to 5 hours of printing, so there shouldn't be any orange filament in there at all. And going through the Anycubic wiki, I finally noticed that my hot end seemed to be missing a piece. There's supposed to be a small ceramic insulator in the throat. Now personally that looks like a PTFE tube to me, but I didn't want to take my chances and just shove a PTFE tube in there, so I reached out to the Anycubic support, supplied them with a picture showing that that piece was missing, and they shipped me a new hot end. I did get this printer pre-release, so hopefully this is just an unfortunate pre-production oversight, but if you happen to be having the same problem, then this may be where you want to start looking. But with that little bit of drama out of the way, I'm happy to say this is the point at which my experience with the printer turned a lot more positive. So I've had a project on the back burner for a little while, and I figured the Anycubic Kobra S1 would be a good printer to help me get this thing done. What you're looking at is a 1:1 scale model of a car brake and wheel hub assembly. I modeled this entire thing off of real vehicle parts, but of course simplified many of them for 3D printing. And if you look at the section view, you'll see that there's a spindle, and inside of the wheel hub, there are real tapered roller bearings. This bearing configuration is from a real vehicle setup, as I wanted the hub and rotor to spin freely. Normally on a car, all those features on which the bearings would sit and interface with would be CNC machined. And since I'm working with 3D printing and the tolerances can be a little less predictable, I had to print a bunch of these test parts. Rather than printing the full models, I've sectioned off small parts where the bearings will sit, and then you'll see the spindle there as well, and I can print this in one shot so I can just test fit the bearings. If it turns out to be too loose or too tight, I can make those slight adjustments in the model and then iterate very quickly. And to save time printing these two models, you can see that I've actually nested the two one inside of the other because they do not interfere with one another. If you can do that with your models, this kind of approach will save a little bit of time when it comes to the print head wasting time traveling from one part to another. For the tube looking piece, these are the surfaces inside of the wheel hub where the outer portion of the bearings would sit. And to get this to print properly, I had to add some support material, and you'll also see that I added an outer brim. Otherwise, there's just a small ring of contact on this part on the print bed, and I was concerned that it might get knocked over. Other than that, I didn't really make too many major adjustments to the print profile, and I love using the print preview feature here where you can drag through all of the individual layers and just make sure there are no weird issues. Nothing here looked amiss, so I went back into the Prepare tab in the top left corner, added my washer, as well as adding the castle nut, which, if you're not familiar with cars, holds the wheel bearing assembly in place and will provide a minimal amount of preload to those bearings. So I'll be sending this off to the Anycubic S1 and I'll be printing it in their orange PLA. Now once in the Workbench tab, you'll notice on the bottom left corner under that big black box there is a play button, and by pressing that button, this is where you can begin to start the webcam stream from the camera inside of the Kobra S1. These are some of the first prints that I performed after fixing that hot end issue that we discussed in the previous section of this video. And immediately after fixing the hot end, I could tell right away that the surface quality of all the parts was so much better. Now, unfortunately, this shade of orange isn't really the best color to see all of the fine details of the print, at least on camera. But hopefully you can see how nicely those external threads printed, especially when they were interrupted by those holes, which are intended for cotter pins to work with the castle nut. I really tried to keep this model as realistic as possible. Even inside of the castle nut, you can see the internal threads look quite nice, and the big test here is how well they fit together. Now in the model, I did modify the threads to be easier to 3D print. For example, the thread pitch is larger than normal, and there is more of an offset between the male and female threads, just for a little more space. But it was nice to see that they did fit together. Now the big test was trying to get the fit with the bearings correct. So again, we've got these two parts here, the spindle and then the hub test piece, and you can see my tapered roller bearings. Now, unlike spherical roller bearings, the two parts of the bearing can come apart quite easily. One is the inner raceway or the cone, and the outside part is called the cup. The bearing preload is adjusted by forcing the cone into the cup, and you'll see in the final assembly how this kind of makes sense. But first, what I'm going to do is I'm going to push the cup inside of the hub piece. I was shooting for a light interference fit between those two parts, just so that the cup wouldn't fall out and the cone would sit comfortably inside. So this is the inner bearing. The spindle will push through from this side, and I was also looking for a pretty light interference fit between the spindle and the inner raceway. Now we can move on to the outer bearing, and in the same manner, I'm going to be pushing in the cup into the hub piece and then putting the inner raceway on top of that. And this fit was also quite good. Now we can slip on the washer and screw on our castle nut. And based on the real dimensions and tolerances of these parts, it only took me 2 iterations on the Kobra S1 to get everything where I wanted it. I was pretty surprised that I only had to make very minor adjustments to the real dimensions from the vehicle in order to get the correct fit. And whenever I get a new printer, one other thing I like to try is test fitting parts that were printed on another printer, especially from a different brand, and seeing if the new printer prints kind of on the small side or on the large side. And in this case, these purple parts were printed on a Creality printer, and the two fit together perfectly. In my project, I also have some smaller fasteners that need to be printed, so I went ahead and test printed some of those parts. For example, some M8 and M10 threads. The spindle thread was an M16, so these are considerably smaller, and I did find that some of these smaller threads did require some minor cleanup. But once I got those threads cleaned up, they did still fit together perfectly fine, so I was very confident that once I print the final models, everything should go together smoothly. It's also worth noting that I did modify the thread properties for these smaller bolts as well. So again, I increased the pitch and modified the threads to be more coarse so that they are easier to 3D print. And if you're looking to 3D print your own nuts and bolts, I would highly recommend that you take this approach as well if you have the ability to in your 3D modeling program. So now that I felt confident working with the tolerances of the Anycubic Kobra S1, I went on to print the full wheel hub. And you'll notice at the top of the hub, we've got 5 threads sticking up. Normally on a vehicle like this one that it was modeled after, those studs would be pressed in from the back, but because this is being 3D printed, I just integrated threads directly into the hub. At the bottom of the hub, I'm going to paint on some support material that needs to be there for the shoulder surface where the inner bearing seats. And in order to make that support material easier to remove later on, I'm going to make some slight changes to the support properties. So in this case, I'm using the normal manual supports. I'm going to use a snug support style, first layer expansion of 3mm. I've changed the pattern spacing to 2mm, and the XY distance from any walls, I've increased that to 0.5mm so it doesn't accidentally fuse to the model. Now in terms of the infill, I want to save a little bit of material, and the threads need more infill and strength than the rest of the model. Therefore, I'm going to go into the Objects tab, right-click on the model, and add a height range modifier. And if you're not familiar with height range modifiers, what you can do, you can section off a model into different regions based on the Z height, and from there you can assign different properties to those regions. And infill density is one of those properties that you can change. So what I'm going to do here is I'm going to set a global infill density of 25%, and then inside of that height range modifier, I'm going to reduce that. So you'll see when I go to slice the model, and then we take a look at the print preview, the density is much greater above the height range modifier, and below that, it's less dense. So now I have a bit of extra strength where I need it, and in the sections where I don't need it, I'm just going to use a little less material, and it might speed up the print slightly. If you haven't been skipping through this video, you may recognize this part from earlier, and this is one of the parts that I couldn't get to print while I had that hot end issue. This time around, however, it finished without any drama, and the results look pretty spectacular. The vertical walls look extremely smooth, and the layer lines are almost not visible at all. This is at a layer resolution of 0.2mm. The 45-degree overhang looks extremely smooth as well, and the threads are very clean. And although the printhead would have had to travel from thread to thread, each of those threads turned out perfectly. Tilting this part down, we can take a look at the top surface, and this was also extremely smooth. There were no signs of over extrusion or under extrusion on that top solid layer. The support material on the bottom was, however, a little bit difficult to remove, and maybe those settings could use a little work, but I can go in there and remove the rest of that with some kind of a tool. Overall, a very nice part. Moving on, I'm going back into the slicer, and I've imported the files for the legs that hold up this entire model. I'll be printing these in black PLA, and the brand that I'm using does typically require a slightly higher print temperature than most other PLAs that I've used in the past, so I've gone ahead and increased that. And because these legs are going to be holding up the entire model, I also increased the wall count to 4 walls for a bit of extra strength. Now these pieces aren't that big, so they only took about an hour and a half to print both of them, but when they were done, these parts also turned out just as well as that gray hub that I showed you earlier. Even under harsh lighting conditions shining down on this black PLA, you can see how consistent the top layer is, and it looks pretty impressive. There were only a few very small areas where I thought there could be some small improvements. The tabs on the side came out looking very clean, no stringing or anything of that nature there, and the text beside the tab was also crisp and sharp. These parts don't have very tall sidewalls, so there's not a whole lot to look at in that regard. However, they also look very clean. I chamfered all of the edges, and the chamfers are at 45 degrees, and all of those look very nice, and the first layer was also consistent. No signs of the nozzle being too close or too far away. And since I was already printing with black filament, I went on to print the brake rotor hub. The brake rotors themselves are intended to look like a 2-piece rotor. The 3D printed version will actually be made up of many pieces, more than just 2, and that's of course because we're going to have to assemble it in some sort of a clever way so each of the pieces can be printed. I'm going to print this piece in the orientation as shown, and that's just going to limit the amount of small areas where support material is needed for these overhangs, and it just so happens there's also some holes in those overhang areas, so I really had to increase the support density. This approach worked reasonably well, and the support material in this case came off pretty easily. There's only going to be some minor cleanup in the hole area. But the other thing I really liked about printing in this orientation was the fact that the face, which was touching the print bed, gets that awesome texture coming off of the build plate, and that face will be very visible in the final model when it's on display. And so this part overall looked very good, and if I were to be very nitpicky, my only minor complaint would be on the 45-degree overhang. There were some layer lines that you could kind of see under certain lighting conditions. Again, this lighting that I'm using is very harsh, so it really makes these minor things stand out, so I'm not too concerned about that. On what would be the back side of this model, this is the top surface of the print, and again, like all of the other prints I've shown you so far, it looked very good. I'll now be switching back to some gray PLA, and this part is also part of the brake rotor model, but the interesting thing about this part, and we'll see how the Kobra S1 performs, is there are many of these bridges. You'll notice that I left them completely unsupported, so we'll see how those turn out. While the first layer of this part was going down, I did notice towards the back of the build plate, the nozzle was printing a little close. However, I let the print run and it didn't seem to have any impact on the quality of the rest of the part. All of those bridges came out looking fantastic. There was minimal drooping on all of them, and the cool thing about this part is that because all of these bridges are in a circular pattern, it theoretically tests the part cooling at pretty much all angles, and if all of them are consistent, then the part cooling is pretty good on this machine. Next up is the spindle, also intended to be printed in gray PLA, and of course it has that large male thread at the top, but you'll also notice some smaller female threads on this part as well. Earlier in the video, I already printed test pieces with these exact same thread profiles, so I'm not too worried about how these should turn out. And in terms of the print profile, there's really nothing special going on here, so we'll send this off to the printer and we'll see how it goes. This was a nearly 4-hour print, and during that time I was able to keep a pretty close eye on the machine, and everything went according to plan. No drama on this part either. Even before pulling the print off the print bed, I could tell right away that the quality looked excellent. The surface of the spindle was very smooth, so I was very confident that the bearings should fit in the exact same manner that they did on my test pieces, and the male thread at the top of the spindle also looked very good. Similar to the other parts that I've shown so far, I was very impressed with the quality of the top surface layer, and along the sides of the print, even where the nozzle had to change directions abruptly, I didn't see any signs of ghosting or ringing, and the first layer looked very consistent. I really couldn't ask for much more in terms of quality out of that part. Continuing to use the exact same gray PLA, I went on to print the remainder of the fasteners. Now when it came to these, the smaller threads were a little more hit and miss. Overall they were pretty clean, but there were some areas that I did need to manually clean up, but they were still completely functional. After that, there were a few more single color parts that were fairly simple, so I'll go through these rather quickly. There are the brake pads, which again, the top surface looks great, the walls look great, and the first layer was also very consistent. Those were done in the black PLA. A little more challenging of a part here was one of these retainer pins. This will get inserted into the brake caliper model, but the more challenging thing about this part was that it was very tall and thin, and it printed great with just a small brim added, did not get knocked off the print bed, and then there's a small C-clip here, which interfaces with this retaining pin, and the tolerances and dimensions of these parts worked out perfectly as the C-clip snapped nicely into the retaining pin groove. Getting those dimensions right for a snap fit is always very satisfying. This entire time we have been using the ACE PRO to print all of our parts, but up until this point they've all been single color, and now it's time to dive into some multicolor parts. In the fourth slot I've loaded in some gold PLA, and this stuff has been sitting around for a little while, so I'm going to activate the dryer. So I'm going to change the drying temperature to 45 degrees and then simply toggle the dryer button to the on position. The drying time was set to 4 hours, so I'll let that sit for a little while, but if you want to get printing before that, you can absolutely print while the dryer is activated. Back in Anycubic Slicer, I'm going to load in a model of one of the lug nuts, and again this is a part with more female threads. I'm going to be printing it upright in this position. And this is a single body part, so we're going to have to do some work in the slicer to get it to print in multiple colors. I want to perform a color change towards the top of the lug nut, so I'll go into the objects list, I'll right click on the object and add a height range modifier. I'll make an adjustment to that layer range from 0, which is the print bed, all the way up to 27 millimeters, which is the point at which I want the color to transition. And then all I need to do is click on that layer range in the object list, and now I can use the number on my keyboard to change the color of this region. So I'll just press the number 4 on my keyboard, and that corresponds with the filament slot 4, which is gold. When you use this method to paint your models, what you'll notice is that if you're in the Prepare tab, you won't see the color of the model change. You need to proceed to slice the part, and then in the Preview tab, you can see the transition from gold to gray. In the print statistics on the right-hand side, I want you to notice that this model will take 40 minutes to print, and it gives you some information on how much filament you're using for the wipe tower, as well as how many filament changes are being performed, and how much time is being wasted to material flushing. But one key thing that I see missing here is how much material in grams is being wasted to flushing. And that's a statistic that I really like to know because it gives you some sense of how much material is actually being wasted. So it would be pretty good if Anycubic added that pretty standard feature back into their slicer. And for those of you guys who don't have a lot of experience with multicolor printing, one tip to greatly reduce per part waste as well as per part print time is to print multiples of the same multicolor part in a single print. If you recall, it was going to take 40 minutes to print one of these parts, and printing 5 is only going to take an hour and 40 minutes. But more importantly, we're still only performing 2 filament changes despite there being 5 parts on the print bed, and this is most important when it comes to filament waste, because essentially we're going to be wasting the exact same amount of flushed filament despite printing 4 more parts. And this becomes a very big deal when you start to print more than one of the same part requiring hundreds of filament changes. But now focusing on the print quality of these lug nuts, you can see that the color transition from that sparkling gold to that matte gray is definitely very sharp. There were no signs of the two colors bleeding into one another on any of these lug nuts. The internal threads look pretty good, although I did notice if you look deep enough into the part, for some reason on the gold filament, the thread had some areas that were looking a little bit stringy. Moving on, I now need to print the 2 halves of the brake caliper, and one of those halves is just a single color red, so we're not going to be covering that, but the second part is a multi-body part in which I've put my logo on the front of the caliper. With multi-body parts, it's extremely easy to change the colors. Again, you just hop into the object list, select the parts, and then I personally like using the number keys on my keyboard to assign new filament colors to those parts. So you can see that I've painted the objects that make up the logo white and the rest of the caliper body remains red. Some areas of this part will require some support material, so I'll make some adjustments to those settings to try and get the absolute best surface quality of the supported surfaces, and in most cases I find that can be achieved by reducing the base pattern spacing as well as the top interface spacing, essentially making that support material a little more dense, and that just prevents those supported surfaces from drooping. But one setting I'd like to turn your attention to achieve a smoother looking first layer, especially if you've got a color change on there with some kind of a logo, is the checkbox in the quality tab that allows you to change the first layer wall count to 1. So you can see once I check that box and then reslice the part, I now only have 1 outline or wall layer around that logo, and that generally makes logos, especially with fine details, look a lot more sharp. So go ahead and give that a try if you get the chance. I will send this file off to the printer, and I'll keep a close eye on this one to capture this color change on the first layer. So you can see that it started with red, and then once it's finished printing the first layer in red, the print head moves towards the front of the machine, sweeps to the back, and then parks itself in the back left-hand corner where it's going to purge the red filament, cut that red filament, and then the ACE Pro is going to retract it, and then it will feed in the white filament, which will be next for the logo. And I've sped this section of the video up, but you can see that it proceeds to purge some of that white filament, wipes the nozzle, and then deposits some of that on the prime tower. There should be no remnants of red filament left at this point, and when it goes to print the white logo, you'll just get pure white filament with no color bleeding whatsoever. And while you guys are watching some more of this print go down, one other thing I want to point out that I didn't mention when we were in the slicer was that another feature that Anycubic has seemed to disable inside of their slicer is the ability to change the flushing volumes. Some slicers give you more control in this area in order to reduce the flushing volumes at the risk of color bleeding. It's possible that they've disabled this so that you can't end up with a bad looking part, as they probably don't want ugly looking parts associated with their machines. And I can kind of see where they're coming from, but if you're a more advanced user and you want that kind of function, then you may have to slice your parts in Orca Slicer. Taking a look at this part here, you can see that overall it looks very good, although some of the supports were more difficult to remove, and that's likely a function of me changing the support settings to increase the density. And the only area of this part that didn't quite meet my expectations was this section here where you'll find a small amount of stringing, and this is likely due to a very curved and steep overhang where the caliper body is filleted. I ended up cleaning it up with a hobby knife, but the logo itself looked very sharp and the whole project turned out excellent. I'm going to publish a separate video going further in depth into this project, the design, as well as the printing and assembly. So be sure to subscribe so you do not miss that video, but overall, I was very happy that the Kobra S1 was able to make this project possible. Now I'll take you through another multicolor part, and I'm going to drag and drop a 3MF project file that was made for a different printer. Now I could have downloaded the STL and imported that, but because this is a single body part, that means I would have had to manually color all of these little sections of the model. And that can be very tedious, so a better strategy here is to just import the 3MF, change the printer, so you can see in the top left hand corner I switched from a bamboo printer to the Anycubic Kobra S1, and the model itself retains all of the colors. Now one other thing you may have noticed is that it was imported with 5 colors and I only have 4 slots in the ACE Pro, so I've deleted the brown color and now I only really have to paint a small section of this model. The 2 stripes on the back of Pikachu were originally brown, and I could have spent some more time potentially painting those stripes black, but nobody's really going to see the back of this model, so I went ahead and used the brush to paint them yellow. This will save a bunch of printing time. Now the other thing that I need to do here is change the filament profiles. The 3MF project file was using some bamboo filament, so I switched it back to the Anycubic profiles, and to make this part a little more interesting, I'm going to increase or scale the part size by 250%. Scaling the model does not affect the color painting, so don't be afraid to experiment if you want to customize the scale of your models. And I'm going to leave most of the other settings as is, and you'll see that I left the wall count at 2 instead of increasing it to 3. In the multi-material tab, there is an option to flush into the object's infill, and this is an option that you can potentially use to try and save some filament. However, there is a catch to this, and this is a perfect model to demonstrate what might happen if you use this option. And that's because this model has very light colors, such as the yellow, and very dark colors, such as the black. So you can see in the print preview, as I scroll down the layers, there will be black infill filament inside of the layers where the outer walls are yellow. And so the strategy here is that some of that filament, instead of being purged, is being used on the infill where theoretically you shouldn't be able to see it. So we'll see how that turns out. And one final thing I want to point out is that when you are doing multicolored parts, I would recommend that you take a pretty thorough look at the print preview. And you can see somewhere down in the bottom of this Pikachu that there is some random white filament in there, and this should be a solid yellow section. So there appears to be a few unnecessary color changes going on in this region, and going back into the preview tab, I was able to identify that when I went to paint the stripes on his back, I missed some very small spots. So I went back and more thoroughly repainted those sections, and now you can see I'm not unnecessarily wasting more material or time in that region of the part. Now despite those small gains, this was still a 19-hour print with about 330 filament color changes. The color changes are all crisp and sharp, and the printer did exactly what it was supposed to do. No complaints there. But I did want to use this model to show you that how in an attempt to save a little bit of filament and flush into the infill, you can actually see some of that black infill through the yellow walls. Ultimately, I didn't really save much filament doing this, so I wouldn't recommend doing that unless you plan on increasing your wall count so that it won't be as transparent, or if you're using different colors that do not have so much contrast between them that you don't risk seeing one through the other. But otherwise, I thought the Kobra S1 did a fantastic job with all of those color changes. I've got one final example here, and it's another project that was set up for a different printer. So again, I've gone ahead and imported that 3MF project file, changed the printer, and now I'm removing some of those extra filament colors. And you can see how the bodies that were previously assigned to those removed colors get automatically reassigned. And then I need to use the button to synchronize my filaments from the ACE Pro, and then reassign those colors to the bodies in the object list. And now everything looks perfectly fine again. However, this part takes up almost all of the print bed, and one thing you'll notice is that the purge tower was actually located inside of the part. So I've gone back into the prepare tab, and if you're not already aware, you can click on the purge tower and you can drag it around to move it so that it does not interfere with your part. After that, I was ready to send the file off to the Kobra S1, and it knocked this part out without any issue, despite this part taking up most of the print bed. There's a pretty good variety of colors in this part, so black, white, red, and green, all of them very different. And you can see that there was absolutely no color bleeding between these sections, and that's very important because this is going to be a light box. The back of this light box was just printed in solid black, so it's not all that interesting to look at. However, it's just worth pointing out that it did turn out just fine, and the first layer was very smooth. I printed and built a few light boxes lately, and once you print one, you're pretty tempted to print more of them because they are quite fun to build and look at once they're done. And my LED preference of choice for the light boxes are these Cob strip LEDs. Unlike LED strips with discrete LEDs, the light output from these is very uniform, and that makes them ideal for these light boxes. The one that I have here is a pure white LED temperature, so it's not on the warm side, and it comes with a touch power switch. Tapping the power button turns them on and off, and holding your finger over it will make it brighter or dimmer. If you're interested in these LEDs for your own projects, I'll put a link to them in the video description down below. To attach the two halves of the housing together, I just used some simple hot glue, and once you hook up a power source, you can see how nice the result is, and I'm sure you can imagine all of the possibilities of 3D printed light boxes. In the past, I had heard good things about Anycubic printers, and this is my first one. I was interested to see what their latest machine had to offer, and now that I've spent more time with it, I'm very impressed with the overall print quality and performance. It was unfortunate that my experience did start off a little shaky with that faulty hot end, which was missing the insulator inside from the factory, but at least they were able to quickly send me a replacement part once the problem was identified. After that was fixed, it was very much smooth sailing, and the print quality and reliability improved significantly. The print profiles in the slicer were very good, and I didn't really need to do any further tuning, which I thought was nice. I loved how reliable the Wi-Fi connection was from the printer to the slicer, and this may seem like a trivial thing, but lately I noticed that some of my printers from other brands like Bamboo Lab and Creality have been having connection issues on my network, and it gets kind of annoying to transfer files by USB once you've been spoiled with a wireless connection, so that's really become a necessity. The quality of the machine build seems to be on par with other printers in this price range, and it looks aesthetically nice as well, so I've got no complaints there. I only have a few minor criticisms of this machine. One of them is the start print sequence. The ACE Pro seems to perform some kind of self-check procedure to ensure that there are no filament jams, but it does this with every single roll. So even if your print only requires one color, this means you'll have to wait an unusually long time for the prints to start, and this can get a bit annoying. The other thing I asked Anycubic to change was the statistics for the print time and material usage in the slicer. Most companies right now are using some kind of Orca slicer derivative for their own machines, and most brands with multi-material units show the amount of flushed filament used in a multicolor print. And for some reason, Anycubic has decided to disable this in the slicer, and this is also a bit annoying because I want to know how much filament I'm about to waste in a multicolor print. It can be a considerable amount, and at this point, we all know it. It's not exclusive to Anycubic machines, so why hide it? I hope they bring that feature back. And finally, on the ACE Pro, where the filament is fed in, there's no short piece of PTFE tube guide like on some of the other multi-material units from other brands. I don't know if this is a patent thing, but not having that guide tube can pull the filament at a bit of a sharp angle, and some of my more brittle filaments had broken a few times as a result. At least two of these three things are probably easy software fixes, so I hope to address those with future software updates. So overall, I think the Kobra S1 is a good buy in this price range considering the competition. If you're already the happy owner of another Anycubic printer, then the S1 would make sense as an upgrade if you're someone who is brand loyal. And if you're coming from outside of the Anycubic brand, I think you'll still be satisfied if you're looking to change things up. And so that's it for this video. Thank you guys so much for watching right till the end. If you value this kind of in-depth content, please consider subscribing, as I've got a lot more videos coming up that I think you'll really enjoy. Also, please remember to check the video description down below for all of the resources mentioned in the video. And if you're looking for an Anycubic printer, use the affiliate link below to help support my channel. It goes a long way. See you guys next time.